Good morning. Welcome to another class, a C++ programming class. So today's topic will be on decision and iteration. All right. So decision making in C++. One of the most important facets of programming is the ability of a program to take different course of action depending on the input to the program, or depending on the current calculated values or the condition of a variable, right? So your program must be able to incorporate some decision-making features, and it will take you to different sections, or it will display some different features based on your input. So we make decisions every day, and your program must be able to capture decision making. All right. So it gives some features if you are able to meet certain criteria. It gives you another feature if you are unable to meet the criteria. All right. So which course of action to take is decided by a conditional statement. So a conditional statement is a statement in which a condition is evaluated and the result determines which path the program control takes, right? So it evaluates a condition, and if the criteria is met, then it will decide on which path it will take you to. Now, in decision making in C++, now C++ provide a standard set of comparison operators that will help you evaluate this condition, and this condition will be either a true, which is 1, or a false, which is 0. Now you have to make some comparison. All right. If the pin, when you slot in your card to your ATM machine and you input your pin, if the pin is correct, the ATM program, the program will tell you, okay, which transaction do you want to what? Do you want to make? If the pin is correct. So it has to compare the pin maybe with an existing stored pin, and will make decision based on that. Now, for you to do this comparison, we have some operators. Some of the operators is what? The relational operators. So in relational operators, we want to look at two conditions or two variables, and we want to test if they are both equal, maybe they are greater than each other, less than, and the rest. So we have relational operators. So in mathematics, if you want to see if two numbers are equal, you use a single equal to x equals to 3. You want to determine if x is 3. You say, oh, is x equals to 3? But in C++, if you want to compare two arguments or two variables, you have to use what? The double equal to. When you're making your comparison, you have to use the double equal to. All right. So in mathematics also, if you want to check if, let's say, a variable is less or equal to a certain number, in mathematics you say less or equal to. But in C++, you follow more like the way you speak it. Is x less or equal to 3? So this is the way we write our what? Our comparison in C++. Likewise, in mathematics, you're greater or equal to, but in C++, this is the way you write it. greater or equal to. In your less than is the same, your greater than is the same, both in mathematics and in C++. In mathematics, if you want to say if a variable is not equal to another variable or a number, this is the way we write it. But in C++, we say not, the exclamation mark stands for not equal to. Now, sometimes we want to make some logical comparison. So you need your operators. Your operators helps you to evaluate two or more variables or conditions. So you have your AND operator, so which is represented by the double ampersand. Why? Because a single ampersand stands for address. We use a single ampersand in C++ for address. So for an AND operation, you need two ampersand. So you could do, okay, is x, if x is less than, let's say, 3 and x is what? Is greater than, let's say, 0. If it's less than 3, so you are trying to look as for x between the range greater than 0, that is to say 1 and 2. You want to see if x ranges between this boundary. So for all, you use these two pipe. For not, you use your exclamation. All right. So let's move forward. That's decision making in C++. All right. Now, we also have what we call the unary operators. Unary, it means it works on just a single variable. Just a single variable. It tests just, let's say, a variable. So the unary operator, one of it is this double plus, which stands for increment. The double minus stands for decrement by 1. Double plus stands for increment by 1. Not if x is you're looking for the inversion of x. So if x is 0, the inversion will be 1. And if x is 1, then the inverse will be 0. Now let's see some examples. Let's see some examples how we can use our operator. Now we want to say, is A greater than B and C greater than D? You follow the way it's written, is A. Now A greater than B. And how do you write your AND operation? You use your double ampersand. And C greater than D. Is E greater than H? Or, so how do you write your or? Double pipe. E greater than D. Is A the same as M or the same as what? Q. So is A the same, that is to say equal to? So if you want to write in C++, if you want to write equal to, you want to compare if A is equal to M, you use the double equal to sign, because a single equal to means assignment. But when you're making decision, you're comparing, you use double equal to. Is A equal to M or A equals to Q? Is B greater than C and C is less than E. All right. So let's move forward. All right. Now, one of the statements we'll ever use in C++ is the if statement, in making decision. If the if statement. And the beauty about C++ or C is a high-level language. The keywords are more are English-like. You want to make a decision, like everyday decision. You ask yourself, if it's raining, then I need an umbrella. If so, if a certain condition is met, then I will do this. If there is something available, then I execute it. Otherwise, it will not execute. So it's not an aberration for us to see an if statement in as part of the keywords and making decisions. So this is how we do it. You use the if statement to make decision. If, and in your bracket, you put your condition there. So you can just say if you open your bracket and say x, if x is greater than 0, and you close it. So if this condition is met, if this condition is true, so let's say x is 3, is 3 greater than 0? Yes, it is true. Then it will execute the statement following it, right? So if this condition is true, these statements are executed if the condition is true. Else, it will be skipped if it is false. So let's just say if it is 0, is 0 greater than 0? No. 0 is equal to 0, is not greater. So the statement in between these braces will not be executed. All right. So we need to note that if there is only one statement to be executed, the braces are not required. Yes, these braces, opening brace and closing brace, is not required, right? So the brace are needed if more than one statement is to be executed. If you need more than one statement to be executed, then the brace. Else, it is just only the first line that will be executed. If only the first line that will be executed. All right. So another thing you need to note is don't put a semicolon after the condition. So after this condition, don't put a what? Semicolon. So it means you won't be able to execute this statement. Don't put. These are the rules. All right. So let's move on. Now let's look at an example. Some example using the if statement in making decision. So let's say if an angle is greater or equals to 0.0 and the angle is less or equal to what? To 19.0. So maybe you want to test if the angle ranges is between 0 and what? 90. So you can see our logical operator. You can see our logical operator here. Sorry, I'm coming. So you can see our logical operator, you can see our relational operator. So for the statement here to be executed, this must be true Likewise, the angle also must be less or equal to 90 before the statement here can be executed. Now, because we have a single line statement, you can decide to ignore your braces. You can decide to ignore the braces. But, it's good programming practice and for legibility to always put your braces, but you can actually ignore it for just a single line statement that will be executed. All right. So now, if we just want to test just for a condition, you can use if my gas tank is less than 0.25, display to the screen get gasoline. Get gasoline and also wash your window. And also wash your window. So you want these two statements to be executed if your gas tank is less than 0.25. Now, because it is more than the statement is 2, more than 1, you will require your braces. You will require your opening and closing braces, and you put your statement there. Else, if you ignore your braces, only the get gasoline would be automatically executed. Well, this also will execute because that's the after executing this, the program has already terminated, or the test condition has already terminated. It will continue execution. But for you to guarantee the execution, you always put it in braces. So you can see examples of how we use our if statement. Now you can also test, we are in the voting period, and for you to vote first, you have to be a Nigerian. So if your nationality is equal to Nigeria, and for you, you need to understand that you would have declared this variable nationality before, you would have assigned it a value, a string of value, right? You would have assigned it a string of value. So here we are now testing. We are making decision. If your nationality is Nigeria, the statement in the brace will be executed. Now, just let me imagine my nationality is Nigeria. Then this is true. Then the statement in the brace will be executed. Now, if my age is greater or equal to 18, then it will display what? I am eligible to vote. I am eligible to vote. So what I'm trying to explain here is you can have a nested if statement. And if inside another if. This if statement is inside another if. You can have a nested if statement. I can tweak this and just write, and if my nationality is equal to Nigeria and my age, I would have declared a variable called age and assigned it a value, or ask the user for a value. Is greater. Now, this is mathematical. So if you want to write it in C++, how do you do it? Let me erase it. How do you do it if you want to write it in C++? So I'll just say if age is greater and equal to 10. I will just say you are eligible to what? Eligible to vote. All right. So let's move on. All right. Let's see. Okay. All right. So there are some pitfalls as a newbie programmer. There are some pitfalls which you need to avoid. So let's look at one of the pitfalls. Okay. So look at this. You've already declared a variable called choice, and choice is true, declared as a boolean. Now you want to test if choice is true. Sometimes when you are when you're writing your program, you you tend to forget um that you use what? You use your double equal to. Excuse me. So you want to test if choice is true, you use your double equal to, right? To test if it's true. So you say if choice is equal, you use your double equal to. When you use your single equal to, what you're actually doing is you are assigning choice to be true. You are saying, okay, choice, you're going to be true, right? So, and since choice is true, it means if true, execute this. Every time it will always execute this. It will always execute it, right? This is your assign. What you're doing here is an assignment operation rather than comparison. So don't forget, you're making in C++, you want to test. If it is true, you use your double equal to. All right. So if you use a single equal to, this condition will always be true or false, depending on what you've assigned to it. All right, let's see another thing. So if you say if true, do this. It will always execute because true is what? True is true. True is one. So is your condition one? Is it true? Yes. Because true is true or true is one. It will always execute what? It will always execute this statement. It will always execute it. Now let's look at another pitfall. Some of the mistake people make is after the syntax, if the right if choice is true, you know, we've already corrected this, that this should be what? Double equal to. They then put a semicolon after what? After the if statement. No, this will not execute. It will not allow the program to execute, right? Okay. And we see this, you are assigning a variable 3, a value 3 to your gas tank variable. Because you are assigning it, it is true. Anytime you assign a number apart from 0, then it's true. Then this statement will always be what? Be executed. All right. Okay, so let's move on. Now, sometimes you want to test for more than a condition. You use your if else statement. So you have just two conditions. If this condition is true, let this body be executed. Otherwise, and how do you say otherwise in C++? You use your else statement. You use your what? You use your else statement. Okay. So if this condition is true, this will be executed. Otherwise, else execute this. So if it is true, this condition will be executed. And if the condition is false, the statement here will be executed. Now, sometimes you can have multiple conditions that you want to you want to test. So you use what? Your if else condition. So you start with an if statement. So look at this. If our score is greater than 7 or equal to 70 and our score is less or equal to 100, display to the screen, you have A. Otherwise, else, if score is greater or equal to 60 and score is less than 70, display you have B. So on and so forth. You can have another else if statement. But one thing you need to know that the last statement, will be what? An else condition. So it's more like if else, if else, you know. So you have to complete it with an else statement. Otherwise, so if none of the conditions are met, the else will be what? Executed. The else statement will be executed. So let's move on. Okay. Sorry, I'm having issues with my screen. Let me clear all my drawing. Okay. So we also have a statement called the switch statement. We also have what we call the switch statement. Now, in a switch statement, the value of the variable is examined and an expression may be used and evaluated too. If the value is one of the values in the case statement, the associated statements are what are performed. So what you do is you test the value of a variable. Now, when you test the value of a variable, you now give it an option, a predefined option. So if this value is, let's say, is A, do this. If this value is B, do this. If this value is C, execute this statement. So in switch statement, you switch to the case appropriate depending on the value you've what examined. Now you need to understand that the break statement causes the program to what jump to the closing brace. So it jumps to the closing brace. If none of the case values are found, the statements in the default statement are performed, right? So it's just like our if, else, if. So if none of the condition in the if and else if statement is found, the last option, which is the else, is performed. Likewise for what? Our case switch statement, if of the case, none of the value is found in the case statement, then the default statement are performed. Now, you need to note that if the programmer forgets the break statement, the program continues what? Executing the case statement without breaking or jumping out of the switch. All right. So, okay. So let's see how we use our switch statement. Now look at this program. You have a variable I score of the data type int. You ask the user, please enter your score, and the user input is our score. Then you divided the score because the score is an integer. It's declared as an integer. When you divide it by 10, the value will the result you will have will still be what? An integer. yes, your value will not be a floating point value. It will be an integer. So if you have um, 73 divided by 10, your result would be what? Will be 7. Will be 7. Will be 7 rather than 7.3, right? But if you say 73.0 divided by 10, then your answer will be what? 7.3. So we want to write a program that depicts the example we did earlier on if else statement, trying to display the appropriate score or grade of a student, whether the student has an A grade, B grade, and the rest. So, like I said, the score, because it's declared as an int, when you divide it by 10, it will remove the decimal part. So you have the whole number part. So this takes care of any number in the range of 7. That is to say 70, 70 up to 79. When you divide it by 10, you will still be having 7, right? So if your when you perform this operation and if you have 7, it will take you to what? To the case 7. When it takes you to the appropriate case, then the statement here will be executed. So you have C out, you have an A. So suppose you have your score is 65. 65 divided by 10, you will have 6. So it takes you to this case, you have B, and it will terminate, it will exit. Now, it is important you use a break statement. Now, imagine I did not include my break statement. What will happen? Suppose my score is 76 divided by 10. You have what? 7. Switch 7. That is to say, switch 7. Take me to case 7. So if I don't have my break, it will execute. You have A, you have B. That's what will be executed. So for other case, you have case 5. So if the student score between 50 and 59, so you have C. Likewise, now suppose the student had any other score that is not listed here, you will have the default statement will be printed. You have F. So that is what will be printed. Okay. All right. So let's move on. Let's move on. All right. So let's look at another example of this switch statement. So let's say I want to guess your favorite fruit. Please enter the first letter of your favorite fruit. So you input the first letter of your favorite fruit. Let's say the first letter of your favorite fruit. Let's say my favorite fruit is apple. So the first letter, which is A, it will take me to this case A, because A is what? A is an alphabet, so you have to put it in what? In single quotes. So you might input a small letter A or a capital letter a small letter A or a capital letter A. It will still come to this case and display to the screen. Is it apple? So you can also do for this if it is banana, if it is carrots, or cantaloupe, I don't know how it's been pronounced. So else, if none of your option, let's say Z now, you input Z, then the default, because Z is not part of this case, then the fourth will be printed. That is to say, I can't guess your favorite fruit. All right, good. So let's move on. So we've done two examples now. We want to take care of an integer case and want to take care of what? An alphabetical case. All right. So let's move on to what we call iteration or loop. Loop. An iteration enables the program to loop over or repeat statements. Sometimes you want your program to execute a statement repeatedly, maybe until you are tired or you are done with the program. You just want it to keep looping or to repeat a statement or a process. Then what you're doing is you're doing an iteration. This iterative process may be set up so that the loop is executed a predetermined number of times or until a certain condition is met. So if you know the number of times you want this statement to be executed, fine. Or you want it to keep repeating until a certain condition is met. Look, like your CPU, you want, okay, the operating system to keep running until maybe you shut down or you press your power button. That's when the operating system, process is terminated. All right. So one of the statements we use is the for statement. So we are looking at for loop now. We are looking at for loop. The for loop is a convenient C++ statement for use when the programmer knows exactly how many times the statement must be repeated. Now, you use your for loop when you know the number of times your statement must be repeated. Now, this is the syntax for the for statement, for the for loop. The keyword, which is the for, you open your parentheses. Now, you have to do what we call an initial assignment. Your initial assignment or your starting criterion is very important, or your followed by your stopping criterion. Your starting criterion followed by your stopping criterion or the condition to test. You do this. Then you do what we call the loop test update. You need to update your loop, right? So this is how you write your first statement. Then the statement to be executed, if condition is true, is placed in what? In braces. So the initial assignment, or what we call the starting criterion, we have the condition to test, or what we call the stopping criterion, because you want to loop. So you want to start, you have a start point, you have an end point, and the number of times you want to jump or you want to increment. So you have what we call the loop test update or the incremental step. This section takes care of the incremental step. So if you have a series, how many times do you want to jump, So let's say you have 1, 2, 3, 4, 5. You just have this number 6, 7, 8. So let's just use a for loop. Maybe you want to loop. Maybe you just want to be jumping. Now you need to start from somewhere. Maybe you want to start from 1, or you want to start from 2 or 3. So any number you're starting from is your initial assignment. So let's say I started from 1. So my initial assignment is 1, right? Now, the condition to test, you need to test your stopping criterion. Where do you want to stop? Okay, let's assume I want to stop at 8, or when the number is below 8. So you start from 1 and you ask yourself, how do I want to increment my step? Do I want to take just 1 step or 2 steps? So if it were to be 2 steps, so 1, you jump to 2 or 3, you jump to 5, you jump to 7. So you can't jump anymore. Why? Because you're stopping at 8. So this is the where you stop, right? So for the first statement, you always have an initial assignment, or what I call the starting criterion, the stopping criterion, and what the incremental step. All right. So that's how you use your first statement. All right. Let's look at an example of how we use our first statement. Now, you declared a variable I of the data type int. I is an integer variable. So you want to display to the screen hello world 50 times. You want to display what? Hello world. How many number of times? 50 times. So how do you do it? Rather than saying, writing see out hello world, see out hello world, see out hello world 50 times, that's crazy. So 50 times. What if it is a million times? So it means you just have to be writing it. No. So with our first statement, we want to write hello world to the screen. You just use your for loop. Now you use your for loop when you know the number of times you want a loop, or you want to iterate. You know the number of times you want to loop a statement, or you want to execute a statement, or you want to iterate. Then you use your for loop. So you ask yourself 50 times, okay. So if I'm displaying this thing 50 times, let's say my starting criterion is 0. So if I start from 0, then if I'm incrementing by 1 step, this plus plus I means increment by 1. If I'm incrementing by just a single step, that is to say 0, 1, 2, 3, 4, 5, do you understand? Just by a step. So if I start with 0, then I must end at 49, because 0 to 49 is what? 50 steps. 50. But if I start at I equals to 1, then I have to say, okay, I have to stop at 50. So then it has to be less. I must be less or equal to 50. So that's 50 times. So my starting criterion is I is equal to 0. I'm stopping when I is less than 50, that is to say 49, and I'm incrementing by 1. So this statement, hello world, will be displayed to the screen 50 times. 50 times. So let's look at this diagram. The first thing is you perform your initialization step. That is to say, I equals to 0, right? The next step is you have to check, is my variable, or what I will say my counter, is my counter less than 50, my stopping value? Okay, 0 is less than 50. That is to say, yes, it's less than 50, and it's true. Now, the third step is the number 3 step. If true, perform the loop. Then it display to the screen hello world. After doing that, it updates. You have to update again. So I becomes 1. So Since I becomes 1, it checks, is 1 less than 50? Yes, that is true. It comes again to display hello world. It increments again, I becomes 2. Is 2 less than 50? Yes, it displays hello world. It increments to 3. Is 3 less than 50? Yes. Now, when it gets to 49, is 49 less than 50? Yes. So let's say you get to 49 now. We started with what? With 0. So it gets to 49. Is 49 less than 50? Yes, it's less than 50. It still executes hello world. It displays hello world to the screen. Now, it increments 50. Is 50 less than 50? No, 50 is not less than 50. 50 is equal to 50. So it stops. It jumps. You can see it what? It jumps to the end. That is to say, it does not execute the statement anymore. It jumps. So let's say I want to write 1,000,000 times. I want to display 1,000,000 times. You don't need to write cout hello world 1,000,000 number of times. Just use your for loop. Start from 0 or 1 and end at 1,000,000, and you increment your step. Now, this is when you just want to use a single variable. What if you want to test for more than a variable? So you just want to test. You're starting with x equals to 0. That's x equals to 0. So x now is 0. Y is what? 100. So what do we say we do? Now it checks is 0 is x less than. Now for this statement to be executed, you can see our AND operation. Is 0 less than 50? Yes, that is true. And is 100 greater than what? 30? That is true. So this statement here will be executed. Then it increments. So then x becomes 1, y becomes what? Y becomes 99. It asks again, is it's 1 less than 50? That is true. Is 99 greater than 30? That is true. It executes again. So that's how it executes up to now. Is, let's say you get to x is, let's just say your x is 50. 50, then let's say your y is what? Let's say your y is also 50. So is 50 less than 50? No. And is 50 greater than? Yes. But it will not execute based on what? The violation of 50 less than 50. So with this, you'll be able to display about 50 times. You execute this statement about 50 times. All right. So for you to iterate, keep executing a statement, you use one of the statements you use, or the keyword is what? The for statement. All right. So let's move on. Now, when you know the number of times you want to execute a statement, you use the for statement. But if you don't know the number of times you want a statement to be executed, you use the while statement. So the while loop is needed when the programmer does not know how many times a loop is to be executed. So when you don't know, then you use your while statement. So since the condition is checked false, it is possible that the loop will not execute. Now, let's go back. Look at this. The while statement can be used to perform a loop an exact number of times. You can also use it to perform a loop a certain number of times. So this, the syntax, you write just like your for loop. You write what? Your keyword while, you put in your parentheses, your condition. So if this condition is true, then this statement will be executed. So let's say x, previously you've assigned x to be 5. So, and maybe in your condition, you're saying, excuse me, is x less than 100? You can see is 5 less than 100? Then yes, true. So because it's true, this statement will keep, will always be executed. The statement will always be executed. So you can also use your while statement for more than one condition. So you can say, let's say y is equals, previously, let's say y is equals to 10. And you can say, and y is greater than 0. So you can see that this statement will be executed. Why? Because x is less than 100 and y is greater than 0. So these two conditions are true. Then the while statement will be executed. Okay. So the while loop checks the condition if it is true. The loop statements are what? Are performed. If this condition now is false, then this statement are skipped. So the computer will continue executing other statements. So to avoid becoming stuck in an infinite loop, a more complete form for this loop includes an initializing statement and a loop altering what statement, right? So that you avoid an infinite loop, you need to have what we call the initialization statement and your loop. So you can also do whatever you can do in for statement or for loop, you can also do it in what? Your while statement. So in your while statement, you can have a starting criterion, you can have a condition, and you can have your incremental step. We'll see that in the next example. All right. So let's see this how we can execute our example earlier using a while statement. We did this using the for statement, so let's see how we can use it in a while statement. All right. So we want to write to the screen, hello world, how many number of times? 50 times. So you have your initialization. This, your initialization or your initial criterion. Count is equals to 0. Initial condition or initial criterion. Count is equals to what? Is 0. Now, this is this is the stopping criterion. When are you going to stop this loop? When count is less than 50. That is when you will stop this iteration or this loop. when what? Count is less than 50. So you can see count is 0, right? Is 0 less than 50? Yes. Then it will execute this statement. It will show hello world on your screen. Then you increment your count. This is the loop altering statement. You increment your count. Then count becomes 1. Is 1 less than 50? Yes, it display hello screen. It will increment your count to 2. Is 2 less than 50? Is 3 less than 50? Is 4 less than? When it gets to 49, is 49 less than 50? Yes, it executes. Now it increments count to be 50. Is 50 less than 50? No, this is not true. When 50 is less than 50, when your count is now 50. 50 is not less than 50. 50 is equal to 50. So it will exit out of this loop. It will exit and come to the next one, to the next statement. It has exited. So you see goodbye. That's what you will see. All right, let's look at another example here. Our frame number is 1. That is to say, begin at frame 1. So while frame number is greater than 1 and frame number is less than 10. So your frame number, your starting criterion is 1. So when your frame number, so it will display keep balling. It increment the frame number to 2. Is 2 greater than 1? Yes. And is 2 less or equals to 10? Yes, it's less than 10. So it will, you are using a logical AND operation. And for AND operation, both must be true before you can have a true output. So you can see while true is true, it will execute this. So when it's at 9, is 9 greater than 1? Yes. Is 9 less or equals to 10? Yes. Now it display keep balling. When it's at 10 now, is 10 greater than 1? Yes. Is 10 less than 10? No, but is equals to 10? Yes. 10 is equals to 10. It will execute again, keep balling. It will increment frame number to what? 11. Is 11 greater than 1? Yes. But is 11 less than 10? No. Is 11 equal to 10? No. So your output is what? Is false. So it will stop this loop. It stops this loop and continue with any other statement that is. All right. So let's continue. Now we add our while loop. The next loop we have is what we call the do while loop. So it is very similar to the while loop, except that the condition check is performed at the end of the loop. So it means, what this invariably means is that the loop statements are always performed at least once, unlike the for and while loop, where the condition must be true before the loop is executed. So look at this do. Do, look at the word do. Do is more like execute this thing. Execute it. Perform this operation. So it performs the operation, it performs this statement before it checks the condition. So that's why they call it the do while loop. It first of all do as long as this condition is true. Then, so what it's saying is it will outperform the loop statement just once. So when it executes, if the condition is false, then it won't continue the loop. But at least it has executed once. Why? Because it is this do statement that precedes the while statement, or that precedes the condition. Assume, unlike the while statement where the condition is first of all checked, the while statement, the condition is checked before executing the statement. So if this condition is not true, that is false, this statement will not be executed. But at least even if this condition is false, it will first of all execute this statement before it's what. So let's continue. So let's use our do while loop to what, to also display hello world to the screen 50 times. So what do? You initialize count to 0, that is to say that's your starting criterion. You're starting at count 0. So you display to the screen hello world, do, you see your do this. So it displays to the screen hello world, then it increments. That's your step, right? It increments. Now in the last class, you know, you can see this plus plus count means increment count by 1. That is to say count equals count plus what? 1. Or you can use a shorthand way where you say count plus equal to 1. It still means the same thing. It means the same thing with this. What if you want to increment by 2? Then you come here and say count plus equals to 2. So what you're actually doing is you're saying count plus 2 should be, when you increment your count, but because it performs the operation from what? Right to left. So if count is 0 initially, so plus 2 means count is 2, then it overrides the initial 0. It becomes 2, right? So here, your incremental steps, so count becomes 1, while 1 is less than 50. Yes, 1 is less than 50, it comes again, it displays hello world to the screen, it increment counts to be 2, is 2 less than 50? Yes, it display hello world to the screen, it increment to 3, it's 3 less than 50, and the rest. So when it increments, when it gets to 50, is 50 less than 50? No, 50 is not less than 50. 50 is equals to 50. Then it stops. It stops executing and it displays goodbye. So you can see that whatever you can do in your for loop, you can also do it in your while loop. You can also do it in your do while loop, as long as you stipulate your starting criterion or starting value, your stopping criterion, and what? Your increment. All right. So let's see if we so that's the end of the class. I would create a practical class where I'll write a program to display all these to the screen, right? But you have an assignment. I want you to read on ternary operator in decision making. Ternary operator in decision making. All right. I want you to read on break, continue, go to return statement as regards program control. And I want you to write what? A program to display the multiplication table that up to what? 12 times. I want to test your knowledge on how to use a for loop inside a for loop. So you can use a for loop inside another for loop. a nested for statement. Yes, you can use that. So I want you to try that out, and also to execute um, to write a program that will display what help you calculate the surface area of a sphere. The formula is given, and also the volume of the sphere. And also I want you to incorporate what? I want you to incorporate a loop that keeps running the program until the user wants to what? Wants to stop. All right. So I'm going to stop my class here, and um, later give you a practical class where I'll be programming, I'll be coding and showing you all this stuff. All right. Take care.